Imagine you're floating in space, alone, silence all around. In the distance, something catches your eye, a swirling, pitch-black void, a black hole. It doesn't glow, it doesn't roar, but it pulls on you, invisibly, unrelentingly. Today, we're diving into one of the most terrifying and awe-inspiring questions in modern astrophysics. What happens if you fall into a black hole? This journey will stretch your imagination, and maybe your atoms too. A black hole is not a hole. It's a place in space where gravity is so strong, nothing, not even light, can escape it. They're formed when a massive star dies. When its nuclear fuel runs out, gravity wins. The core collapses under its own weight, creating a point of near infinite density, what physicists call a singularity. Surrounding the singularity is the event horizon, the boundary where escape becomes impossible. If you cross it, you're gone, forever, at least from the perspective of our universe. So what would it be like to fall in? Let's imagine you're heading toward a stellar mass black hole, a few times heavier than our sun. At first, nothing seems strange. From far away, it's invisible. You only see the light from nearby stars and gas being pulled into it, heating up, glowing, dying. But as you approach, things start to distort. Space bends, light curves. Stars behind the black hole begin to smear into halos. You're not just looking at space, you're watching it collapse in real time. Then you reach the point of no return, the event horizon. Cross it, and the outside universe will never see you again. Now, the real horror begins. In a stellar mass black hole, gravity increases so rapidly from your head to your feet that your body would be stretched lengthwise and compressed sideways, like spaghetti. This process, yes, really is called spaghettification. The difference in gravitational pull is so intense that your atoms would be ripped apart long before you get near the singularity. To someone watching from a distance, you'd appear to freeze at the event horizon, and fade into darkness. But from your point of view, you keep falling, endlessly. But what if it's a supermassive black hole, like the ones at the center of galaxies? These giants are millions or even billions of times the mass of our sun. And here's the strange twist. Falling into one might not kill you right away. The event horizon is so far from the singularity that tidal forces are weaker. You wouldn't feel much at first. You might not even notice when you have passed the point of no return. You could float past the event horizon peacefully, in complete silence, until time and space warp around you beyond recognition. In Einstein's universe, gravity isn't just a force. It bends time itself. As you fall deeper into a black hole, time dilation kicks in. For you, time passes normally. But for the outside world, your clock slows down, drastically. In theory, if someone watched you fall in, you'd never quite cross the event horizon. You'd freeze there for eternity. But for you, inside, things move forward. You fall faster. Reality twists, and the laws of physics as we know them begin to break. What happens next? No one really knows. You might hit the singularity, a point where gravity is infinite, and space and time collapse into a zero-volume nothing. Or, some theories say you could pass through a wormhole, a bridge to another place, or another universe entirely. Maybe you'd be torn apart atom by atom. Or maybe you'd be reborn somewhere else. All we know is that nothing, no light, no signal, no probe, ever escapes to tell us the truth. Black holes are terrifying, but they're also beautiful. They remind us that the universe is still full of mystery, things we may never understand, and maybe that's the most exciting part of all. If you want to keep exploring the cosmos, subscribe to Celestial Guide, where wonder and science collide.